Hey everybody, Mr. Grove here. Today we want to go over the answers to your worksheet packet that had the karyotypes and the Punnett Square problems. So let's jump in and get started. So our first one was our karyotypes, and so we want to know if this is a boy or a girl. So we go down to our sex linked, and this would be a girl. And then we want to know if it's Down syndrome or not. So we go to the 21st chromosome, and there's only 2 of them, so that would be no on the Down syndrome. And then we want to know if the circled chromosome is an autosome or not. And so that would be an autosome because 1 through 22 are all the autosomes. So girl, no, and yes, that's an autosome. On this one, so boy or girl, so we go down to the sex chromosome and we see that we have an XY, so that would be a boy. We go to the 21st pair and we see that there are 3, so that would be Down syndrome. And the circled chromosome is an autosome because, again, it's one of the 1 through 22s. So that's those. Let's move on to the next set. So on this one, would we be a boy or a girl? So it's an X chromosome, XY, so that would be a boy. For Down syndrome, we just have 2 of the chromosomes here, so no Down syndrome. And then is it an autosome or not? Well, the circled one is actually circling the sex chromosome pair, so that would not be an autosome. And then on this one, boy or girl, so we are XX. So girl, Down syndrome or not. So our 21st pair, it's kind of hard to see which is the 21st, but that's this one. And there's actually 3, so that means we would be Down syndrome. And then is the circled chromosome autosome or not? Well, it's the 3rd one, so 1 through 22 are autosomes. Okay, next we had some pedigrees. So what are the following genotypes of each of the following people? Shaded represents homozygous recessive for blue eyes. So that means we can go ahead and put all of the blue-eyed people in right there. And so everybody else is going to be big B something. We just don't know what. But we'll try and figure those out. So in the case of Brent's parents, Larry and Sally, we know they both had to have a little b to give Brent, so that means they would both be big B, little b. Okay, Bill, we know he's got brown eyes, so he's big B something, but we don't know exactly what he would be. Because mom and dad could have given him a double big B, or they could have given him a big B little b. So we're going to have to leave him question mark. Let's jump down here. So we know Brooke is big B something, but she has a daughter, Allie, that was a little b, so that means she had to have a little b to give. And then Brent only has little b's, so his kids are guaranteed to have 1 little b. Now over on this side, we know that Sue is going to be big B something, Bob is going to be big B something. We know somebody's got a little b, but there's no way of knowing who that somebody is. So these guys are all going to have to be big B question mark. Okay, and that would be our pedigree there. Let's try this one. So dimples are dominant to no dimples. Shaded represents dimples. What are the genotypes of each of the people? So no dimples are going to be the homozygous recessive. Okay, so we can call that little d, little d. So we have to make sure you're looking at your key carefully. So shaded represents dimples, so non-shaded would represent no dimples, so the little d's. Okay, so once we got those in there, we know everybody else is going to be big D something. Well, D and Deb had to be big D, little d, because their kid Jesse was little d, little d. Tyson was big D something, but we don't necessarily know what. We do know their daughter Jessie has to be big D, little d, because Tiffany only had a little d to give. So Tyson we don't know for sure. And then Jim is big D because he's shaded and dimples are dominant. And we know he has to be big D, little d, because Dad only had little d's to give. So that would be our pedigree for that one. On this pedigree, so we've got straight hair as dominant to curly, and shaded represents the homozygous recessive. So homozygous recessive, so that means we can be like little, let's call it S's, I guess. So little s, little s, little s, little s, little s, little s, and little s, little s. Okay, so we know, so that means everybody else is going to be big S something. Okay, so we know Rebecca is going to be big S, little s, because Dad over here, Gunnar, only had a little s to give. Rachel, also big S, little s, because Dad only had a little s to give. Nikki, big S, little s, because Leah has the little s, so one from Dad, one from Mom. So we know Nikki can be big S, little s. Jen is going to be big S something, and we know she has to be big S, little s, because her son Brett was little s, so she had to have a little s to give. Over on this side, we know Brent and Krista would be big S, little s, because their son Gunnar only had little s, but Ethan is going to be big S question mark, because we do not know if he's big S or big S, little s. Both of those would be possible. So those are our pedigrees. Okay, now we've got some Punnett Square problems. So Ben is heterozygous for brown eyes, so that means big B, little b. Sarah is going to be also heterozygous for brown eyes, so big B, little b. So our Punnett Square would look like this. What are the odds of a blue-eyed kid? One of those four squares, so 1 and 4. What are the odds of two brown-eyed kids in a row? Well, that would be 3/4 times 3/4, so 9/16. And then what are the odds of a brown-eyed girl? So on that one, we'd have 3/4 for the brown eyes times our 1/2 for the girl, so that would be 3/8. Okay, so that was that one. Moving on, black fur is dominant to brown fur. So if we have a heterozygous black fur dog, big B, little b, heterozygous, crossed with a brown homozygous recessive, so that'd be little b, little b. So our Punnett Square would look like this. What are the odds of a brown furred pup? So that would be 2 out of the 4, so 1/2. What are the odds of a black furred pup? 2 out of 4, so we can say 1/2. What are the odds of 3 brown furred pups in a row? So that'd be 1/2 for the first one, 1/2 for the second one, and 1/2 for the third one. So all of that multiplied together would be 1/8. Okay, moving on. Albino is recessive to gray fur. 2 albino mouse are mated. So we can call those little g, and little g. So our Punnett Square is going to be pretty straightforward. Lots of little g's. What are the odds of a gray-furred baby mouse? Well, 0, because all we have is albino. What are the odds of an albino baby mouse? 100%. Or if you do fractions, 4 out of 4. What are the odds of a female baby albino mouse? So 1 out of 1 for the albino part, 1 out of 2 for the female part, so 1/2. So basically it's just 50-50 for boy, girl. Moving on, in pigs, curly tails are dominant to straight. So a curly-tailed pig is crossed with a straight-tailed pig. So we've got curly-tailed, let's not do that, let's say, so curly tails are dominant, so we'll do C, and then straight, we got a curly tail just crossed with a straight, so we have little c for our straight-tailed pig. And so we don't exactly know this one. So it could be big C to give us curly tails, or it could be big C. So if we were big C, we would expect our Punnett Square to look something like this. And we would expect 50% chance of a straight-tailed pig. Well, we had 12 piglets and we had 0. So that kind of tells us either we're really flipping a whole lot of heads in a row, or maybe it wasn't big C, little c. Okay, so since it wasn't big C, little c, since we had 12 in a row, it's probably more likely to assume, rather than flipping 12 heads in a row, that we were just big C. So that means our Punnett Square would look like this. And all of the offspring would have to be curly-tailed because they were dominant. So that are the genotypes of the parents, big C, little c. Okay, now we have our dihybrids. Okay, so brown hair is dominant to blonde, brown eyes dominant to blue. So mom and dad are both heterozygous. So that means the possibilities of their genotypes are here and then here. So when we crunch these Punnett Squares, we get this, we get this. We get big A, little a, big B, and then big A, big B, little b. For this row, we get that and that. Oops, sorry, that's actually big A. And then we get big A, little b, big A, little a, big B, little b, and then big A, little b. For this one, big A, little a, big B. And we get big A, little a, big B, little b, little a, big B, and little a, big B, little b. And the last row, big A, little a, big B, little b, big A, little b, little b, little a, big B, little b, and then little a, little b, little b. Okay, so what are the odds of brown-haired, brown-eyed? Okay, well, here's brown hair, brown-eyed, brown hair, brown-eyed, brown hair, brown-eyed, brown hair, brown-eyed, brown hair, brown-eyed. That's blue, brown, 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 brown. We got blue, blonde, 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 and blue. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So, in answer to our question, 9/16. The odds of brown and blue, brown hair, blue eyes. So on that one, we got, here's a brown hair, blue eyed, here's brown blue, and here's brown blue. So that's going to give us 3/16. Blonde haired, brown eyed. So here's blonde and brown eyes, blonde and brown eyes, blonde and brown eyes. So that's going to give us 3/16. And then the only one that's left is 1 out of 16 for our blonde and blue-eyed. Now, if we would have done just 2 small Punnett squares, so if this is our hair color, and then this would be our eye color, so brown-haired, brown-eyed, so 3/4 times 3/4 for eyes and hair, and that still gives us 9/16. Brown hair, 3/4 times blue eyes, 1/4. 3 times 1 is 3, 4 times 4 is 16, and that still gives us 3/16. For blonde, we had 1/4 times 3/4, still 3/16, and for blonde and blue, that was 1/4, 1/4, and that would give us 1/16. Okay, another dihybrid. So in apple trees, tall and sweet are dominant to short and sour. So a heterozygous, tall, sweet. So that means our possibilities are tall, big T, big S, big T, little s, little t, big S, and little t, little s. Because we are heterozygous, is crossed with a short and sour. So those are both the recessives, so that means all we have here is little t, little s, 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 because short and sour, the genotype would be that. So only little t and only little s to give here. So our Punnett square would fill out big T, big S, little s, big T, little s, little s, little t, big S, little s, and then little t, little s, little s. Here we would have the exact same thing. And here would be the exact same thing. So all of these would be big T, little s, and all of these would be little t, big S, little s, And then these would be all little t, little s, little s. So, tall and sweet, that's going to be all of these guys. Tall and sour would be all of these guys. Short and sweet would be those guys. And short and sour would be those guys. So in answer to our questions, tall and sweet would be 1/4, 1/4, 1/4, and 1/4, because 4 out of the 16 were all of those. Now if we had done this with the 2 Punnett squares, so we'd have for tall, big T, little t, crossed with short was little t, little t. So that would look like that. And then our heterozygous crossed with our homozygous for the sweet sour. Oops, sorry. Okay, so for tall, we'd have 1/2 times our sweet 1/2, and that would give us 1/4. For tall and sour, 1/2 times 1/2, also 1/4. Short and sweet, 1/2 times 1/2, giving us 1/4. And short and sour, 1/2 times 1/2, giving us 1/4. So that is that. Dihybrid Punnett Square, you can do it either way. Okay, so on this one we got a trihybrid. We're not even going to try and do our 64 squares, so let's just do our 3 little ones. So big A, big A, big A, little a, big A, little a. So that first Punnett square looks like that. Okay, then we had for our B's, those were both heterozygous as well. So it's going to look like that. And then for our C's, those were both heterozygous. Oops, sorry. So they are going to look like this. Okay, so for this one we had 1/2 times 1/2 times 1/2. So that would give us a 1 and 8. Okay, for this one we had 1/4 for big A, 1/4 for big B, and 1/4 for big C. So that means we would have 1 in 64. For this one we had 1/2 for big A, little a, 1/4 for big B, and 1/4 for little c. So 4 times 4 is 16, times 2 is 32, so a 1 in 32. And then on this one we had 1/4, 1/4, 1/4, which gives us a 1 in 64. So those would be our trihybrid answers. Okay, another trihybrid. So we have big L, little l, crossed with little l. So our Punnett square looks like that. Big M, little m, crossed with little m. So our Punnett square looks like that. cross with a little n, little n. So our Punnett Square looks like that. So what are the odds of the following genotypes? So here we would have 1/2, 1/2, 1/2. So that would be 1/8 for our answer. Here we had 1/2, 1/2, and 1/2. So also 1/8 for our answer. Here we have 0 for all of those, so no chance for homozygous dominant. And then here we had 1/2, 1/2, and 1/2. So 1 and 8 again. Okay, then for our sex-linked, so Pam is a carrier for the colorblind gene. Frank is not colorblind. Okay, so that means she is female, so she's XX, but one of those X's is colorblind. Frank is male and is not colorblind. So that means their possibilities would be having a girl that is not colorblind, a girl who is not colorblind but the carrier, a boy who is not colorblind, and a boy who has the colorblind gene and a Y, so is colorblind. So the odds they'd have a colorblind son was 1 in 4. Colorblind daughter, no chance, because they'd have to have both X's to have the colorblind gene, and that's not possible. And then 3 colorblind sons in a row would be 1/4 times 1/4 times 1/4. So 1 in 64. Okay, let's try this one. So Jimmy is colorblind, so that means he's got the gene, and he's a guy. Hannah is not colorblind and also not a carrier, so that means she is XX. So our Punnett Square would look like this. So colorblind son, these are the 2 son possibilities, and neither are colorblind, so 0 there. Colorblind daughter, 0 here, because to be colorblind daughter, you'd have to have both colorblind X chromosomes. 2 colorblind daughters in a row, still 0. Okay, so one last one. Todd is colorblind. That means he's got that. And Julie is not colorblind, but she is a carrier. Okay, so our Punnett Square would look like this. So a colorblind son would be this guy, 1 in 4. Normal son, this guy, 1 in 4. Colorblind daughter, this would be a colorblind daughter because they both had the trait. And normal daughter, even though she's a carrier, she would still be normal because she has 1 good X gene. So that would be that one. So those are some pedigrees, some karyotypes, and some Punnett Square practice. And I hope that was helpful. And don't forget to smash that like button.